Hello students in Introduction to Statistics at Salt Community College. This video will give you a brief overview of what you will need to do for the second part of the tuberculosis data project. As another reminder, keep in mind to not include the direct directions in your submission of the project. You should have your own words when you are describing to the reader what you are doing. For the first part of your project, you are going to select 2 of the countries from your 10 that you selected in part 1 of the project. With those 2 countries, you are going to check the 3 conditions for computing a 95% confidence interval. Those 3 conditions should be a confirmation of randomness, that you have randomly selected the country. You should also verify independence, and you also need to verify that there are enough successes and failures. In order to verify both independence and successes and failures, we ask that you use the cohort size as a sample size n, and you can use the sample proportion as the success rate, both of which you should have already reported in part 1 of the project. For example, here I have 3 countries listed. If I select Lithuania and Guyana as my 2 countries, their cohort sizes would be 866 and 485 respectively. So that means for the sample size for Lithuania, I will use 866, and for Guyana, I will use 485. Their success rates, 87% and 71%, I should use in order to verify that there are enough successes and failures. Note that depending on the country that you have, you may find that you do not pass the 3 conditions. If that is the case, or if you do pass all conditions, then make sure that you verify that and explain to the reader that either you will trust the confidence intervals you're about to calculate in step B, or you will not trust them. In step B, you will compute and interpret a 95% confidence interval. In order to compute that in GeoGebra, we can go to the probability calculator, and it likely will open up on distribution. Make sure you go to the statistics section, and because we are doing this for a single proportion for a confidence interval, we will select Z estimate of a proportion. To do a 95% confidence interval, we will select 0.95, and then we'll put the number of successes and sample size for a given country. For example, if I have Lithuania, their cohort size is 866. That's going to be my sample size. For the number of successes, I will take that success rate and multiply it by the cohort size. So 87%, or 0.87 times the cohort size of 866, I expect about 753 successes. I will round that to the nearest whole person and plug in 753 out of 866 for Lithuania. This will give me a lower limit and an upper limit for a confidence interval. Be sure to include a picture of this output for the confidence interval, and also make sure you interpret the confidence interval you find. Reminder, you will do this for both countries from section A. Once you are done with that, for section C, you will then see if the global threshold of 85% is a possible success rate for a given country. For example, the one that I did for Lithuania, Lithuania's lower limit is 0.847 to an upper limit of 0.892. 0.85 does lie within that interval, so I do believe that 0.85 could be a possible value for the success rate for Lithuania. This will likely be different depending on what countries that you are working with. For part D of the project, you are going to start to conduct a hypothesis test. But before we do so, we need to check our 3 conditions. So, be sure first that you select the same country that you did in part 1 of the project, where you did a simulation. Make sure you select the same country because we are going to have to compare these tests. Also, the 3 conditions should be similar to the 3 conditions you do for part A for confidence intervals, But keep in mind that when you check successes and failures, you need to make sure you use the null value, 0.85. For part E, it'll ask you to show all steps for the hypothesis test, aside from the conditions that were already checked. Be sure you state the two hypotheses, the null and the alternative, show work with the outputs from GeoGebra, identify the test statistic, the p-value, select a value of alpha, I suggest 0.01, 0.05, or 0.10, and make a conclusion in context. In order to do a hypothesis test, in GeoGebra, I select, in this case, z-test of a proportion in order to do a hypothesis test for a single proportion. And I can put in my null hypothesis, which should still be 0.85. And I'm still doing a two-sided test, so I should select not equal to. The successes and sample size will depend on your country. For example, if my first country is France, then their sample size is 4814, and I will have to use the success rate to find the successes. So 4814 times 0.12 gives me about 578 successes. So I'll say for France, 578 successes out of 4,814. Gives me a test statistic of negative 141.8 and a p-value of approximately 0. This kind of situation can happen depending on the success rate and the sample sizes for particular countries, so do not be alarmed if you do get a very large or very negative test statistic. With those values that you calculate, make sure you do an overall conclusion and, yet again, include a screenshot of your output from GeoGebra here. Lastly, you will compare your hypothesis test results to the ones that you had in Part 1, Section D, where you did the hypothesis test using the simulation data from Rossmann Chance. Note that you may have different results depending on what country you have. It will be unlikely that they have the same exact p-values. However, what you will need to do here is explain any similarities and differences. Explain the similarities and differences between the sample sizes that were used, the p-value, and the overall conclusions, and also make sure that you answer the question of, is one more valid than the other in your opinion? Hopefully that helps you out with the second part of the project.